if I have two lines, the three conditions that I can get is this: the lines could be intersecting, or the lines could be parallel, or you can say coincident. It could be coincident like this, just one over the other. And in the third case, they could be parallel. These are the three conditions I can get for two lines. Now let's look up in the first condition. The lines are intersecting. Where are they intersecting? They'll intersect at this point. We call this point as A. So in this case, we can say A is the coordinates of A. A has value x and y. And A, the x and y of A is said to be the solution of these two lines. This point A is shared by both the lines, the green and the yellow. And the point A is said to be the solution. Whatever is the value of x and y, that is the solution of this line, because it lies on both the lines. So how many solutions will this line have? This line will have one solution. Now when we go to the next one here, how many points do these two lines intersect? They are coincident. They will intersect in infinite points. So how many solutions will this have? Will have infinite solutions, because they have infinite points that they meet. And when we go in the last case, we again have these two lines. This is the second case, and now we go to the third case. We have these two lines, and these two lines do not meet at all. Means they have no solutions. Now, if a line has one solution or infinite solutions, they have solution, maybe one or infinite, and that condition is also said consistent. It is said to be consistent. However, we know what is the condition for this: A1 over A2 not equal to B1 by B2. And if it's infinite, A1 by A2 equal to B1 by B2 equal to C1 by C2. If these two conditions come, we can say the lines are consistent. And if there is no solution, we say the lines are inconsistent. And when do we get no solutions? A1 over A2 equals B1 over B2 not equals C1 over C2. So with this in mind, let us do the next sum. So I repeat again, consistent means two cases, either one solution or infinite solution. Inconsistent means this one case, A1 over A2 equal to B1 by B2 not equal to C1 by C2. So here again, on comparing the ratios, find whether the following pair of linear equations are consistent or inconsistent. I'll repeat again, consistent means what? One solution or infinite solutions. Inconsistent means no solutions. So for the first one, I'm good now. Your A1 is 3, your A2 is 2. This is your A1 and this is your A2. And then we have the B1 and B2. This is the B1, which is plus 2, and your B2 is minus 3. And then we have the C1 and C2. So your C1 is 5 and your C2 is 7. So now let's see what is A1 by A2. 3 by 2. And then we go for B1 by B2. B1 by B2 is 2 over minus 3. And then we have C1 by C2, 5 by 7. So A1 by A2 is this, B1 by B2 is this, and C1 by C2 is this. So we see that A1 by A2 is not equal to B1 by B2, because we have here 3 by 2 and is not equal to 2 over minus 3. In this case, they has intersecting lines, one solution. It has a solution, so we can say it is consistent because it has a one solution. One solution or many solutions is consistent. Now for the second one, we have 2x minus 3y equal to 8. And then we have 4x minus 6y equal to 9. So let's write down our A1, A2. So our A1, A2 will be, this is our A1, this will be our A2, so that is 2 and 4. For B1, B2, this is minus 3 and minus 6, minus and minus 6. And C1, C2 is 8 and 9, so that will be 8 and here 9. So we start with the first. A1 over A2 is 2 by 4. So A1 over A2 is 1 by 2. Then we get on to B1 by B2. Minus 3 over minus 6. So B1 by B2 is also 1 by 2. And then C1 by C2. C1 by C2, 8 by 9. So here again we see that A1 by A2 is this, B1 by B2 is this, and C1 by C2 is this. So A1 by A2 is equal to B1 by B2, but not equal to C1 by C2. In this case, we get parallel lines. This is the condition for parallel lines. And you know parallel lines is no solutions. They do not meet. No solutions. And no solutions means inconsistent. These lines are inconsistent. The equations are inconsistent. Here again for the third one, I've written the equation. So we got to see what is our A1, A2. Then we need to note what is our B1, B2. And in the end, we need to note what is C1 and C2. So for A1, A2, this is our A1 and this is the A2. So we'll write here 3 by 2 and 9. C1 by C2 will be here. This is the the B1 and this is the B2. So B1 5 by 3 and this is minus 10. And for C1 by C2, this is the C1 and this is the C2. So this is 7 and this is 14. Now let's see what is A1 by A2. Now it doesn't matter if it's a fraction, the rules remain the same. So A1 was 3 by 2 and that is, so my A1 by A2 will be 3 by 2. Remember my division is at this point. This is my division. So I'll put here divide by and divide by 9. So my A1 by A2 will be 3 by 2 into 1 by 9. And A1 by A2, when I reduce it, will be 1 by 6. We go ahead and find B1 by B2. Your B1 is 5 by 3. Your B2 is minus 10. So B1 by B2 will be 5 by 3. Now see, where's the division at this point? So it is divide by 10 here. So B1 by B2 equal to 5 by 3, and the division changes to multiplication. You take reciprocal. So this also, after reducing, you get 1 by 6. And the last is to do C1 by C2, that is 7 by 14. So C1 by C2 is 1 by 2. Now we look at our ratios and we get here 1 by 6, 1 by 6, 1 by 2. Now here I made a mistake. Have you noticed it was minus here? This was minus. I dropped the minus here. So this is here minus. B1 by B2 was minus. So which means now the A1 over A2 is not equal to B1 by B2, because A1 by A2 was 1 by 6, B1 by B2 was minus 1 by 6, and these are not equal. Not equal, which means the lines are intersecting. If the lines are intersecting, they meet at one point. At this point, they meet at one point. So they have one solution. And one solution means they have a solution. So the equations are consistent. Now for the next set of equations, again like usual, we have to note what is our A1, A2. Then we need to know what is B1, B2. And last we need to know what is C1, C2. So this is our A1 and this is our A2. So A1 5, A2 minus 10. b1, this is the b1, and this the y term, the coefficients of the y, so plus 6, and c1, c2 are the constants, so c1 and c2, so that is 11 minus 22. So a1 by a2 will be 5 over minus 10, a1 by a2 minus 1 by 2. Take care of the negatives. So b1 by b2 minus 3 over 6. So b1 by b2 is also minus 1 by 2. And then last we have c1 by c2, 11 over minus 22, c1 by c2 minus 1 by 2. So here too we have seen this is a1 by a2, this is b1 by b2, this is c1 by c2. And we realize that a1 by a2 equals b1 by b2 equals c1 by c2. So in this case the lines are one and the same. This line and the other line also is on that only. So how many solutions will I say this has got? It meets at infinite points, so infinite solutions, but it has solutions. So infinite solutions, it has solutions. That means it is consistent. The linear equations are consistent. Now again we have another two pairs, and we note what is a1, a2. Now here a1, and this will be my a2. So 4 by 3, and this is 2. And then here you will have b1 and b2, b1, b2, 2 and 3, and last we have c1 and c2, c1, c2. So the a1 over a2 works to be 4 by 3 by 2. So a1, so I've calculated my a1 by a2. Now you go ahead and calculate your b1 by b2, which is 2 by 3 direct. And then the last is c1 by c2, 8 by 12. And c1 by c2 is also 2 by 3. Now if you see your a1 by a2 is this, your b1 by b2 is this, and all of them are equal. a1 by a2 equal to b1 by b2 equal to c1 by c2. So here again we are having lines that are coincident. One line and the other line is also over this line only. Both the lines are coincident. So if they are coincident, they have infinite solution because they meet infinite points. So they are consistent. They have solutions that is consistent.